Okay, so we are officially recording this set of notes because we're going over some details about the content of the chapter. All right, so first things first, your notes are going to be due tomorrow night at midnight. Okay, some of you guys already have them in. That's wonderful. But because of the late work, working on the late work, we shoved the notes back to their due tomorrow night at midnight, Friday night midnight. And I actually said, one of the reasons I wanted to include this in the recording, I actually still have one or two people who are not doing the verification pages right. So in this recording, I'm going to go over it again in case anybody needs it. The verification pages are, you can have your notes 100% filled in absolutely perfectly, but I can't give you the credit for your notes until I see the actual signed verification pages. And typed won't work. It must be signed for real. What we're doing with these verification pages is you are first, you're promising that you have filled in all of your notes. Second, that you watch the teaching videos. The teaching videos are where I'd explain the content. And most of the time our classes are too short and we have one thing disrupting us or another thing disrupting us or technology acting stupid. The teaching videos cover the entire lesson and you can use them at your own speed. You can stop and rewind if something gets confusing. You can watch them again when it's time to study for the test. But the only way I can verify that you've seen the teaching video is to have you sign off on the verification sheet promising me that you have and me trusting you to be truthful. Okay, that's what a signature is. I'm being truthful. Okay, it's a document. Okay, so you're promising me that you've seen the teaching videos because that's where the content is. And then at the third thing that you're agreeing to is that you are reading the notes as you watch the teaching video. Adds an extra layer of learning. The three things your parents are signing that they agreed to is yes, they saw that all of your notes are filled in. Yes, they know for a fact that you watched the teaching video. And third, they ask, do you have any questions? And either your parents can help you figure out the questions or they can get hold of me between the two of y'all. You answer me or you ask me or they ask me if something doesn't make sense. That's the third thing your parents are agreeing to. And then you both sign it. Now, again, it has to be real signatures. It cannot be typed. All right. And some of you guys, your mouse will let you write on the screen. And some of you guys are doing like screenshots and markup and you're drawing it on your phone with your fingers. Any of that's fine as long as it's a real signature. But some of you guys are not able to do those things. And so the best option in that case is to write the verification page onto notebook paper. And it's only about 10 lines long. So you must though, what's happening is I have some people who are trying to recycle their signatures and that's not going to work. So I need, one second, buddy. Dante, is that you just checking in for the role? Dante, is that you checking in for the role? Or is that a question? Okay. Ask me if you have a question, buddy. But right now what I'm trying to go over is the verification pages. If you do write them on the notebook paper, okay, you must have the title and or the section number, like 3-1 notes is what this is going to be. 3-1 notes. You got to have the title on top written in ink. Like I said, I have some people who are trying to recycle these and that's not going to work. So you write the title number on top in ink. You write the 3 things you're agreeing to and the 3 things your parents are agreeing to, and then you sign it. And once you've got it signed, you take a picture of the notebook paper and then submit the picture to Schoology. And that's how you get your credit for your notes. Okay. Most of you are doing just fine with this because we've been doing this since day one. And we have it clear and down, and most of you guys are doing just fine. Some of you guys are still not getting it. All right. Next thing about today is we have this worksheet here. I've got it actually downloaded here for you. All right. I'm going to go over the details on this for you, but it's one of the things I wanted to bring up is that this is only 7 questions. Most of my assignments are incredibly short. Okay. On today is going to be a lot of talking. That's why we're recording it. But most days I say hello, we do our role, and then you start your work. And you have plenty of time to get this done. All right. I'm going to come back to this when we get to the end of the discussion. Right now, I want to talk about, go back to the stuff I want to talk about today. This is the lessons. All right. I want to go cover the, yes, Dante? Yes, Dante? Okay. All right. So the stuff in the stuff in the notes, the content, this chapter, this section is about the Earth's spheres. And we know that she has 4 spheres. Hang on. All right, she has 4 spheres. Let me see if I'm missing something still. Dante, baby, your hand is up. Do you have a question for me? Let me load back up this roll thingy here. Okay, so that when people come in, I can mark them present. Which is difficult on a recording day. But it just goes to show you how important the teaching videos are, because they get interrupted. All right, so, okay. Submit. Okay. Now, the 4 spheres, the geosphere, the biosphere, the hydrosphere, and the atmosphere. They are the Earth's life support system. And just like within your own body, you have your heart, your lungs, your bones, your muscles, your stomach, and intestines, and they all work together. Same thing for the Earth. She has the geosphere, the hydrosphere, the biosphere, and the atmosphere. That's her life support system. And what happens, though, is that not one of them interacts or exists on its own. The geosphere is not all by itself. The hydrosphere is not all by itself. They all interact. Just like in your body, if one part of you gets sick, okay, it's going to affect all of the other parts as well. So the spheres within your body, like the circulatory system, the digestive system, the muscular system, all of those spheres within your body interact with each other. The spheres of the Earth interact with each other. One of the examples is that, like the geosphere. The geosphere, of course, is it's the crust, mantle, and core. This is where you're going to have the volcanoes and the earthquakes. This is the Earth part of the Earth. And that's also where we're going to have all of our fossil fuels and all of the nutrients we need to survive. More people coming in. What's happening to the computer that's kicking you guys out? Which again is one more reason to watch the teaching videos. All right. So the geosphere is where we keep our fossil fuels, and it's also where all of our nutrients are: the calcium, the phosphorus, the potassium, all of the things that every living thing needs to grow. Well, all of the living things are included in the biosphere. Well, if the biosphere things, plants, animals, microbes, bugs, every living thing on Earth is part of the biosphere, and they're getting their nutrients from the geosphere, and they're breathing their oxygen or breathing out carbon dioxide from the atmosphere. Okay, and they're getting the water they need from the hydrosphere. All of them are completely interacting with one another. Now, when we're talking about environmental science, we're usually talking about the bad things that the humans do to the planet, because that's what we're focusing on, is trying not just to focus on bad stuff, but to figure out what the bad stuff is so we can fix it. All right, so when the geosphere, we said that's where you're going to have your fossil fuels. And when we burn the fossil fuel, it's going to add carbon dioxide to the atmosphere, geosphere, atmosphere. It's going to add carbon dioxide to the atmosphere. And then what that happens then is it's going to start heating up the world. This is global warming and the greenhouse effect. That carbon dioxide is going to hold the heat in. And when it does, it starts to heat up the oceans, hydrosphere. So we have geosphere, atmosphere, and hydrosphere already. It starts to heat up the oceans. When the oceans get hot, the corals start to die off. Biosphere, that's all 4 of them. The corals start to die off, and they are the primary component of all the tropical waters. The coral reefs. Okay, if the corals are dead, the whole reef is dead. And the coral reefs are some of the most biodiverse areas of the oceans. Okay, so you have all 4 of these are tied in together with the fact of us overburning the fossil fuels. Then additionally, you see we got a picture of a cow right here on our picture. Do you know that there are more cows? I'm still bringing this in. There are more cows on this earth than there are people. And we know the people are way overpopulated. We've learned this. We've done the whole population thing. There are way too many people on this planet. There are more cows than there are people. Okay, I'm bringing this in. We're talking about global warming and greenhouse gases, right? There are 3 main kickers. There are 3 main kickers big guns when it talks to global warming and greenhouse effect. The three main guns are carbon dioxide, methane, and water vapor. We were just talking about carbon dioxide that happens when we burn fossil fuels. Three main big guns that deal with global change and climate change and global warming. Carbon dioxide. Methane is the second one. Okay, and water vapor is the third, water vapor that we breathe out. And again, water vapor holds heat. These three hold heat. And these three are the reason we have global warming. Okay, carbon dioxide, methane, and water vapor. All right, so carbon dioxide from fossil fuels, water vapor from too many people on Earth breathing out, okay, and the fact of the heating the Earth is starting to, the water is starting to evaporate, water vapor. The third one, methane. All right, methane is actually more powerful in causing global warming even than carbon dioxide is. Methane is more powerful. Now, what does this have to do with the cows? Methane is a natural result of grasses being decomposed. Okay, grasses rotting or decomposing is going to naturally produce methane. Okay, what do cows eat? Grasses. When they eat the grasses, their body digests them, it decomposes the grasses, and methane is released. It's a gas that is released. Yes, I am talking about cow poots, but not just cows, every animal that when they eat grasses, methane is a result. It's a gas that is produced from the digestion of grasses. Now, this methane is actually stronger, has a bigger effect on global warming than even carbon dioxide does. Every time we talk about global warming and we talk about the glaciers melting and we talk about climate change, we talk about too much carbon dioxide, methane is actually worse. And there are more cows than there are humans on Earth. Okay, that's a lot of methane. All right. Additionally, methane is also produced when, you know, permafrost, the frozen ground that's in part of Alaska and Canada, and where the ground is frozen permanently all the time, permafrost. You've learned this in middle school. You've heard this before, permafrost. Because the Earth is heating up, the permafrost is melting. In the permafrost is a whole bunch of old grasses and stuff trapped in the dirt. And if you have like keep vegetables in your freezer, you keep them frozen in the freezer, everything's fine. But if your freezer breaks, your freezer starts to thaw out, all of those bags of vegetables are going to start to rot in your freezer, aren't they? Permafrost is the same thing. There are grasses and stuff frozen in the dirt of the permafrost. If the permafrost starts to melt, those grasses that were in the dirt, they start to rot. They're going to release more methane. And then once they release more methane, the world gets hotter and more of the permafrost melts. And then there's more methane and the world gets even hotter, so more permafrost melts. Do you see how this is a bad thing? So we focus on the pretty bad stuff of, I have some more about when we get into those weird pie charts that are on your worksheet. But the four spheres, geosphere, biosphere, hydrosphere, atmosphere. The four spheres are the Earth's life support system, and they work to help keep the Earth alive, just like our spheres, digestive system, circulatory system, muscular system, they help us keep us alive. Let's move down to the second part for this picture today. All right, the second picture today is, this was one of your questions on the gray box. It was talking about how do energy and nutrients cycle through the ecosystems. That's what this is. Most of you guys were able to find it in the notes. The gray box, those questions were word for word in your notes. I didn't want anybody making up answers. They were all word for word in your notes. But what this means is, when we talk about energy, okay, the Earth is considered an open system when we talk about energy because sunlight can come in and heat can go out. So energy, the Earth is an open system as far as energy because light can come in, unlimited supply, and heat can go out as long as we don't fill the atmosphere too thick. I mean, that's what's happening. When we fill the atmosphere too thick, the heat can't get out as good, but theoretically, the heat can escape. So energy can come in and out of the Earth as it needs to without too much restriction. So as far as energy goes, the Earth is an open system. But as far as nutrients and matter goes, The Earth is a closed system. I'm talking about stuff like calcium and phosphorus and carbon and oxygen and water and the things we need. The Earth is a closed system. To help you kind of think of this through, think about if you've taken a long road trip. Say you've got two siblings in the car with you, or cousins or whatever, two people in the back seat with you. And if it's a long car trip, you guys are they're gonna get on your nerves darn quick. All right. But at least with a long road trip, you can stop at a gas station and like get a bite to eat or go to the restroom to relieve yourself. You can do those things on a road trip. You can stop. The Earth is like being on a road trip that doesn't stop. It's not like we're going to go ahead and stop at the asteroid belt and pick up some more oxygen. We're going to go to the moons of Jupiter and dump off some of this waste that we've made. No, we got no choice. Okay, we are stuck on this road trip on this Earth forever. We cannot leave the Earth. So this is everything we have. So what happens is we have to recycle all of the minerals and nutrients, all of the matter that is in the Earth has to be recycled so that it can continue to be used. And in our next section, we're going to talk about how. We're going to go the carbon cycle, the phosphorus cycle, the nitrogen cycle. That's part of how we keep these nutrients going through. All right, so the Earth is a closed system with respect to matter and nutrients, but it's an open system with respect to the energy because light can come in and heat can go out. So it's an open system as far as energy goes, but a closed system as far as matter and nutrients goes. And that's why we have to take care of what we have because we can't stop and get more. We can't stop and dump this mess that we've made. Okay, we got no choices. So that's why they call it SpaceShip Earth. SpaceShip Earth. There's nothing we can do about it. We are stuck. This is all we got. And it's not like you can boot out your cousins out of the back seat. All right. There's nowhere for them to go. Okay. All right. So that is those two parts. Let me open up your worksheet to get you the second two parts. All right. This is the worksheet that you're doing today. This is going to be due Friday night at midnight. And there's only 7 questions on it. But this worksheet right here, one of the 4 spheres is the atmosphere. And the atmosphere, another one of your gray box questions, it was going over the fact that the geosphere, the gravity of the geosphere holds the atmosphere in place. Okay, the gravity of the geosphere holds the atmosphere here. That's why the moon, it's so much smaller. It doesn't have enough gravity to hold an atmosphere. That's why it doesn't have one. Okay, the smaller moons and planets do not have enough gravity to hold an atmosphere on. The Earth, however, is big enough to hold our atmosphere. Okay, now this atmosphere does a lot of things for it. First, this is where we get our oxygen, so duh, it's real important. It's divided into layers. Okay, there's actually 5 layers. Okay, but we're going to talk today about these bottom 2. This bottom one is called the troposphere, and this next one is called the stratosphere. Now, I did have a couple of guys on the gray box accidentally, when you were trying to list the 4 spheres, you said geosphere, atmosphere, troposphere, stratosphere. Troposphere and stratosphere is part of the atmosphere. Okay, that kind of threw a lot of you guys. Troposphere and stratosphere is part of the atmosphere. All right, now troposphere is the one on the very bottom. It's these bottom 10 miles or so. And because gravity pulls the air on, right? We just said gravity holds the atmosphere. Closer down here to the Earth, there is more air molecules being pulled down here close to the Earth. And the higher up a mountain you go, there are less air molecules because of the force of gravity pulling them downward. Now, that's also why here in Mississippi, because we're close to sea level, down here near the bottom, we are close to sea level. In poor Louisiana, it's even below sea level. So much air has been pulled down that makes it so difficult for us to breathe in the summertime, which is also why when you go up a mountain, it gets cooler. And if you go up the really high mountains like the Himalayas, they actually have to carry oxygen with them, okay, because there's so little air up there because gravity pulled it all down. This part of the troposphere, this is the only place where we have living things. There are no living things on any one of the upper levels. okay, that we know of. As far as not aliens, we don't know for sure if they exist or not, but as far as what we know of Earth, nothing living can exist above the troposphere. Every living thing is down here with us. And this is also the only place where weather happens. Okay, that's all down here in this bottom level called the troposphere. The next level up is the stratosphere. And this here, it does not have any living things in it, but it does have something that is incredibly important to us, this ozone layer. Now, the ozone layer is not a layer by itself. It is part of the stratosphere. Okay, it is a part of the stratosphere. Now, if you look at the diagram here, this shows you what the ozone layer does for us. UVA is just plain ordinary sunlight, and it lets it come through just fine. UVB is the type of sunlight that will burn you. Most of you guys know somebody as light as me, I'll spend 30 minutes out in the sunshine and I turn into a lobster after 30 minutes. I'm burnt, it hurts, it's uncomfortable, it's very painful, and can lead to cancer. You know, the older you get, the more often you get sunburned, the more likely you will have cancer. All right. And so what the ozone layer does for us is it's UVB that burns you. Put the two B's together. It's UVB that burns you. And so the ozone layer blocks 95% of this UVB rays. Do you see this? The ozone layer blocks 95% of the UVB rays. And if somebody as light as me can get burned with only 5% coming down here, can you imagine what would happen if we did not have the ozone layer and all of this UVB ray came down? No matter what color your skin would be, you would be burnt in a minute. I'm talking big blisters and then the skin peeling off, possibly even blackening. It's just horrible. And what they do, you know, if this from this UVB rays, if we did not have this ozone to protect us and 100% of this UVB ray came down, we would just be dead in a minute, because most of you guys have also seen, like when you're at a dentist office or even sometimes in nail shops, when they're putting metal equipment like instruments, okay, they will put them in a UVB light, that purple light that they put them in to sanitize the medical instruments. That UVB kills microbes. That's why they can sanitize the medical equipment with UVB light. And so that UVB is enough to kill microbes. Can you imagine what it would do to us if it all came down all the time? If it kills even microbes, it would kill us in a minute. And this UVC stuff is so scary. And luckily, not any of it comes down. The ozone blocks all of that. What we do know, most of you guys know that there is a hole in the ozone layer. And what happened is because there were certain pollutants that we were using called chlorofluorocarbons, CFCs. Okay, it's a type of pollution that we put out that was breaking a hole in the ozone layer. We were lucky that the hole in the ozone layer, because of the global wind, the hole in the ozone layer settled down near Antarctica, and not many people live there. However, the people in Australia, okay, kids, no matter what color their skin was, had to go out wearing a hat and sunscreen all the time, no matter, even if they were out in the sun just for a little while, because the skin cancer went crazy because that hole in the ozone layer was letting too much of that UVB through. What we found out in the 90s, which was kind of interesting, volcanoes, not all of them, but the biggest of the volcanoes can actually shoot their ashes up into the ozone layer and start to block it up. In the 90s, we had a big giant volcano called Mount Pinatubo that exploded in the Philippines. And we found out that when the ashes go up that high, they can actually repair some of the damage in the ozone hole. And what that led us all to realize is that the Earth can heal herself if we will let her. Okay, so that's so the ozone is not a layer all by itself. It's part of the stratosphere. That's the second layer up. Now there are 3 more layers above it. You have the thermosphere, then the mesosphere first, and then the thermosphere, and then the exosphere. So there's 3 layers above that, but we're really only worried about these bottom 2. Now these 2 here, this was in your book. This is the second part of today's worksheet. These are pie charts. I don't really like the pie charts done this way. They're really confusing, but it really is just a pie chart, I promise. All right, now this first one deals, we have the four spheres: geosphere, biosphere, atmosphere, hydrosphere. All right, these two pie charts deal with the atmosphere on top and the hydrosphere on bottom. So to do the atmosphere one, first off, we know that we breathe in oxygen. So oxygen is incredibly important to us. And because it's so important to us, a lot of us think that oxygen is the biggest percent of the air, but it's not. Oxygen is only about 20% of the air. The rest of it is 78% of it is nitrogen. So only 21% is oxygen. Okay, the rest, 78%, most of the rest is nitrogen. Now, nitrogen is actually in the gas form, it's pretty useless. All right, but at least it doesn't hold heat, and neither does oxygen. So at least it doesn't hold heat. Now, we'll talk about how useless it is in next section when we start covering the nitrogen cycle. So we'll bring that up, and just know right now that nitrogen in the air is pretty useless. But as I said, at least it doesn't hold heat, and neither does oxygen. Do you see this tiny little bit of section right here? Okay, these are the tiny bits. Now, argon doesn't do anything at all, but the carbon dioxide and then the other gases, that's where you get the methane and the water vapor that I was talking about. Okay, so what were the three big hitters for global change and climate change and global warming? Okay, carbon dioxide, methane, water vapor. They are going to be down here with these. The carbon dioxide is listed, methane and water vapor is down here with the other. Now, that is a tiny, tiny, tiny percent of all the air that's out there. And that tiny, tiny percent causes all of this big trouble with the glaciers melting and the world getting too hot and climate change and worse with the global warming and climate change. We have the hurricanes are worse and more frequent than we've ever had. There are droughts bigger and harder and longer, and floods bigger and harder and longer than we've ever had before. Now, droughts and floods are completely opposites. But that's the point. With climate change, the extremes get exaggerated. But now, if we could take this big amount of drought and flood, move some to the middle, then everything would be good. But that's the problem. It's the extremes. Way too dry or way too wet. Okay, that's part of the problem with climate change. All right, and this tiny bit of the atmosphere is what's causing all of this trouble. Yes, we had no idea when we first started burning fossil fuels just how big of an impact carbon dioxide would have. It doesn't take much. This stuff is so freaking powerful. And like I said, methane is even stronger. So the gases that create the change, the climate change, are very, very small percentage of the atmosphere. Now this bottom one counts the hydrosphere, that's the water. And most of us already know the majority of the water is in the oceans. 96.5% of it. So the majority of the water is in the ocean, and that means it's salt water. See the word saline? Saline means salt water. This tiny bit section right here is what's fresh water. All right, let's see. Whoops, lost it. Let me get back to my worksheet. Okay, so hang on. 206. Okay, so this tiny little bit of fresh water right here, okay, this is all that we have to drink. And worse, most of it's locked up here in the glaciers. Okay, glaciers and ice caps. Now you could kind of get a twisted way of thinking. It's like, well, maybe melting the glaciers is a good thing because at least we'll have more fresh water. No, because that's dumping into the ocean. That's not, we can't use it at all. It gets dumped into the ocean and then it's become salt water. But worse, when you have the combination of fresh water versus salt water, when that combination gets off whack, the ocean currents get off whack. Do you remember when you were younger and you watched Finding Nemo, and he was swimming with the turtles? Do you remember that big fast thing where they were swimming in? Okay, that's the ocean currents that I'm talking about. If you mess up the balance between fresh water and salt water, those currents get messed up. And not only, most of the animals depend on those currents in the ocean to get them places, and their lives depend on it, and the different things about their the habitat and the niche and the things that they do depend on these currents. But not only that, these currents affect weather above them. So these currents affect the weather. That's another one where the hydrosphere is affecting the atmosphere. These ocean currents have a big effect on the weather patterns above them. And this is one of the reasons why we're having trouble with El Nino and more global droughts and flooding and hurricanes, because these currents are getting all messed up. All right, and that's because these glaciers are melting into the salt water. So the only thing we have to drink are these other two blues right here. Now, when we get to groundwater, I'm going to say a word that's gotten a couple of you guys stuck. The word is aquifer. Aquifer. We've come across it a couple of times and it's given some of you guys some trouble. What an aquifer is, it's a storage area under the ground to hold groundwater. Aquifer is a storage area either between the rocks or in caves or whatever that can hold the groundwater, and we can tap it with a well to get some groundwater for us to drink from. Okay, so the aquifer is a storage area for groundwater. All right, now this last one, this other freshwater, this is where you get this tiny little bit is the rivers and streams and any rainwater that we could use. Okay, this tiny bit. So that's all we have to drink. So when we damage it, it's just done. Okay, so that's the end of the discussion of these things. I do have one more thing to add. Does anybody have any questions about the material that we've covered today? I know it's been a lot, but it is recording, which is bonus. Shemaya, do you have a question for me?
For salt water, if you boil it, will it not become?
Yeah, you can. It's called distillation, but it takes a lot more with the technology we have right now, it takes a lot more energy to get a tiny bit of fresh water. So we don't have very good technology to make good use of it yet, but the distillation is a possibility. Yeah, Dante, do you have a question? Okay, anybody else with a question? Okay, so I want to bring one more thing up. Oh, it's the end of 6. Well, I guess I won't bring that other thing up. All right, so let me make the meeting note that's over here. Download the attendance list. Remember that stop the recording. Your notes are due tomorrow night, and this worksheet is due tomorrow night. Stop the recording. All right.